according to the second law of motion, the net force is equal to the mass times the acceleration. And we just got done talking about a new type of acceleration, which is centripetal acceleration. And therefore, we have a different force. Whenever there's an acceleration, it arises because there is a force being applied. And so, a centripetal acceleration is caused by a centripetal force. But another nuance to the second law of motion here is that the direction of the force and the acceleration are the same. And therefore, since we said that the direction of the centripetal acceleration is towards the center, hence the word centripetal means center-seeking in Latin, the direction of the centripetal force is also towards the center. But another nuance of this equation is that we have said that this equation was referring to the net force. And so therefore, the centripetal force is really not a new force. It is the total force acting on an object, causing it to move in a circle. So a centripetal force is a force that causes circular motion. It is a vector like all forces, and the direction is towards the center. That's what this centripetal means, center seeking. So towards the center. Symbol for all forces are F, so this is no different. We use a subscript C to designate that it is a centripetal force. And in this class, we're exclusively using the units of newtons. That is the metric system that all scientists use. But the engineers in the United States might use something like pounds. And so that is also a possibility when talking about units for force. So I just want to talk briefly here about that this is not really a new force. This is really just referring to the total force. Centripetal force is a lot like an actor or an actress. It plays the part. Like, you know, if we have a part Hamlet, we might say that John is playing the part of Hamlet. It's not that Hamlet is a new person. John simply plays the part of Hamlet. And so another force is actually acting as the centripetal force. For example, if we have the Earth going around the sun, playing the part of the centripetal force in this case is the gravitational force. They are the same thing. It's not that the centripetal force is a new force that can be categorized as either a contact or field. In this case, the centripetal force is a field force, also known as the gravitational force. If I were to swing a yo-yo around my head, so here I am, and I swing this yo-yo in a circle around my head. In this case, the centripetal force is the tension force. The tension in the string is causing it to move in a circle. They are one and the same. So it'd be like the centripetal force is Hamlet. And different people can play the part of Hamlet. Whether it be the gravitational force or the tension force, they are playing that part. So again, it is not a new force that we are referring to. In actuality, it's the net force that we are talking about. Not just really one or two, but a combination of those examples I just gave. It was actually just one force playing that part. But let's look at an example here down below of a person riding on a circular track. What's preventing this boy from sliding forward is friction. I mean, we've all, unfortunately, I hope that not everybody, but unfortunately maybe some of us have experienced a situation where we are in a car and we try and turn around a corner, but we unfortunately continue moving into maybe a snowbank. And so what's going on is because there's no friction, we do not have that circular motion. The frictional force is playing the part of the centripetal force. But is that the only force acting on the bike? The answer is no. There's also the gravitational force and the normal force. But those forces cancel each other out. And therefore, the net force is the force of friction, which is also then the centripetal force.